So the question is, how do you identify when it's a natural log and when it's not, right? The derivative of the denominator has to be in the numerator, but not just part of it. The derivative of this whole thing would have to be up there. And the derivative of this whole thing is twice x squared plus 1 times 2x. Make sense? So, if you see the integral of sine of x over cosine of x dx, well, the derivative of the bottom is on the top, well, except it needs a negative. So that is the natural log of cosine of x, the negative up front. Because that would be 1 over cosine times the derivative of cosine, which is negative sine, the negatives cancel, and I get that back. But it's got to be, and that's the whole point of this problem is, the derivative of the inside is up there, so this is really what I would call a reverse chain rule. Because the inside here, this x squared is 2x, and that's what's up there. You rewrote this as the integral of x times x squared plus 2 to the negative 2 dx. The derivative of the inside is right there. But this one, right, the derivative of the bottom is exactly 2x. Well, except for the constant, that's what's on top. So I know right away that is a natural log problem. And that's really important. And the reason it's really important is we have three different, this is a rational function, this is a rational function. The next section right over here, trying to figure out how to do these rational functions, so you have partial fractions. Well, the last thing you want to do is tackle a rational function with partial fractions if it's an easy rational function, right? So you want to think, when you see a rational function, 1, is it a natural log? Those are easy. 2, is it a U substitution / reverse chain rule? 3, is it, if this one's flipped over down, an improper fraction? If the derivative of if the degree of the top is bigger than the degree of the bottom, you want to long divide it out. And 4, if none of those apply, then you want to tackle partial fractions, because you don't want to tackle partial fractions unless you have to, because that's one of the more challenging, time-consuming techniques. Okay, who's up next? That was 2 something, 16, 214? 214, who's up? Nick?